Hi everyone, and welcome. Today we're tackling a silent killer of applications, the memory leak. What is a memory leak? Imagine you borrow books from a library but never return them. Eventually, the library runs out of books for everyone else. A memory leak is very similar. Your program requests memory from the computer to store data, but it forgets to give that memory back when it's done. This slowly eats up all the available memory, making your application sluggish, unresponsive, and eventually causing it to crash. It's a serious problem, but don't worry, we're going to learn how to hunt down these leaks and fix them for good. So, how do you even know you have a leak? The first step is to observe the symptoms. Is your application's memory usage constantly climbing over time, even when it's just sitting idle? Does it get slower the longer it runs? These are classic signs of a memory leak. To confirm your suspicion, you need to use a memory profiler. These are powerful tools that watch your program run and track every single piece of memory that gets allocated. For C or C++ developers, a tool like Valgrind is your best friend. If you're working with Java, tools like Visual VM or JProfiler can show you exactly what objects are piling up in what's called the heap. For web developers using JavaScript, the Chrome DevTools has an excellent memory profiler built right in. And for Python programmers, you can use libraries like memory_profiler. These tools will give you a snapshot of your memory, helping you pinpoint which objects are not being cleaned up as expected. Once you've found the leak, how do you fix it? The solution depends on your programming language. In languages with manual memory management like C, the rule is simple. For every allocation, you must have a corresponding deallocation. If you use malloc to get memory, you must use free to release it. In modern C++, it's much better to use smart pointers, which handle this for you automatically and prevent many common mistakes. Now, what about languages like Java, Python, or JavaScript? These have a garbage collector, which is supposed to clean up memory for you. But the garbage collector is not magic. It can only free memory that is no longer reachable by your program. A leak happens when you accidentally keep a reference or a link to an object you no longer need. For example, you might add an event listener to a button. If you later remove that button from the page but forget to explicitly remove the event listener, that listener still holds a reference to the button. The garbage collector sees that reference and thinks the button is still in use, so it never cleans it up. The fix is to be diligent about releasing these references. When you're done with an object, set its variable to null. When you're done with a listener, remove it. When you open a file or a network connection, make sure you have code in a finally block or a similar structure to close it, no matter what happens. To recap, first, watch for the signs of a leak like rising memory usage. Second, use a profiler to pinpoint the exact source of the problem. And third, fix the code by ensuring you release all resources and references when you're finished with them. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and consider subscribing for more programming tutorials and tips. Have you ever fought a nasty memory leak? Share your story in the comments below.